In this video, we'll do a review of property of numbers. Now, most students have these in their background back in early high school days or even in elementary school days, but a little review perhaps is in order. The first property we'll look at is what is called the commutative property. And the general rule of it is A plus B equals B plus A. And all you've done is switch the order around. This is the commutative property of addition, and we also have it of multiplication as well. Well, this should be a B here. And this is an A. Just switch the order around. Now, at addition, you have to put the sign in, and multiplication is implied when there is no sign between the letters. So, we want to illustrate this, and we'll give you a chance. Again, you're going to write these down and see what you can do. So this would be, again, multiplication here. This is going to be y, and then we'd have to put this in parentheses, like so. Because the sign then is associated with the 3. There is no multiplication sign between these two, but I put one in, but you don't need to. And for this one, just reverse the order. 5x plus 14. And again, what property is this when we just reverse the order? The commutative property. All right, now the associative property, let's show the rule of it. A plus B plus C equals A plus B plus C. And you might say, well, wait a minute, they're exactly the same. This is an identity. But we make it the associative property when we put parentheses here and group these two first, and then here grouping these two first. So looking at this, what would be the associative property? In this, we didn't do multiplication. Let's do it. A, B, C equals A, B, C. Again, your parenthesis here, your parenthesis here. The order is the same. The grouping is changed. You do these two first. In this side, you do these two first. And we're saying this is a property of mathematics. These legalize you're doing such a thing. So here we're going to put a parenthesis, negative 7a, and then put the b out here. Again, we're going to write the order the same way. 2x plus y plus 4. But now we're going to change the grouping. So what property is this? This is the associative property. The order remains the same, but the grouping changes. Now here we're going to use the commutative and associative properties to simplify, and this is what we do in math all the time. Now I'm going to switch the order of these two, and I'm going to get 12, put the 5 over here, group that together, and then we have the x. So this would then simplify into 17 plus x. Now this is the background for it. Often we can just do this without thinking of the rules. So here we're going to reorder this. We have used the associative property here by grouping these two first. And notice what happens now when we simplify this. The 8s cancel out, there's a 1. The 7s cancel out, there's a 1. So we're just left with a negative 1, which we don't write now, r. So this simplifies into a negative r. Remember, there's a 1 there, but there's a 1 in front of every letter. We just don't write it. Now, one of the other common rules we have, properties, is the distributive property. Now, this property looks like this, where we have a letter or some value outside the parenthesis, and then terms within the parenthesis, like so. Now, we remove the parenthesis by actually doing what this says. Take A and multiply it by each of these terms. So, A times B is AB. A times C is A plus AC. Now, if this were a negative, then this would be a negative. It's the distributive property. Now, if we took the distributive property and they say there's a common factor of A, how could we get back to this? We'll be using that a lot. And we call that process factoring. We factor out the A from each of these common factors in these two terms. So it goes either way. Now we want to distribute. So this would be 30x minus negative 2 times 6, 12. And distributing, negative 4, that'll be a negative 8y. And negative times a negative makes it a positive 28. Now notice you can do the opposite. Later we'll be doing this in a later chapter, factoring out, which is the opposite of the distributive property. Now, for this one, let me write this out for you. Negative 1/6 times 9 minus a negative 1/6 times a negative 12x. Now, normally you can do this in your head, but, it is a little challenging, so I'm writing it out for you. Now, negative times a positive gives you a negative. You can take a 3 out of there and a 3 out of there, which will give you 3/2. So 6, 3 out of there is 2. 3 out of there is 3. So a negative 3/2. Now here, again, 6 will go into there once. 6 will go into there twice. Negative times negative gives you a positive 2x. The distributive property. Now, from this, it would probably be super difficult to get back to this once you've simplified it. Here, it's a little easier to do that. Now, again, they want you to simplify. So we have to do the distributive and get 12x. 3 times a negative 9 is a negative 27. And then we have our plus 7 here. Now notice, one's negative, one's plus. So we have to, and they're like terms. So this will become 12x. Now a negative 27, a positive 7 gives us a negative 20. So we've used the distributive property to simplify, get rid of parentheses, and then here group like terms. Now here we want to write this as a sum, as a product. We want to go backwards here. Can you see you have a common negative 8 factor here? So negative 8, I'm pulling that negative 8 out, and then in the parenthesis I'm left with an x plus y. This is something you'll run into once in a while. Alright, let's move it up. Now in these last few, we're asked to find the additive inverse, or opposite, of each of the following numbers. So, the additive inverse is what you would add to something to make it a 0. And often, all we do is change the sign. The opposite of this would be a positive 2/3. So now we have this value and its additive inverse, or opposite. When we add them together, it gives us a 0. Now this one's a little tricky. What would be the opposite of a negative 17, but the absolute value? The absolute value of this is 17. Now, what would be the opposite of 17? Well, 17 and its opposite would be the opposite. This is a positive now, would be a negative 17. And that would add up to 0. So this one's a little tricky because you had to convert this to the absolute value of negative 17, which is 17. But they've asked for the additive inverse of 17 now, which is a negative 17, its opposite. Now there's a couple of other properties that they're not illustrating here, and I want to take a moment to do so. And the identity property is we can multiply anything by 1, and that does not change its value. And we use that when we worked with fractions. This is the identity of multiplication. Now, what would be the identity of addition? And the answer is we could add a 0 to anything, and that doesn't change its value. So this is the identity of multiplication. This is the identity of addition. Now, another property is the reciprocal. What can we multiply any number by, let's say a, so that the results would be a1? I guess I put the equal sign in the wrong place there. We want to put a multiplication sign there. What can we multiply anything by in order to make it 1? Of course, 0 would be an exception. And the answer is it's reciprocal. Now, remember, we said any number has a 1 under it that we don't write normally. So what would be the reciprocal of A over 1? And the answer would be 1 over A. Now this is sometimes referred to as the multiplicative inverse. It's reciprocal. What you would multiply something to have it equal 1. So examples of it would be like 5 over 1. The reciprocal, not multiple, is 1 over 5. Now how about a negative 5? Well, its reciprocal would be a negative 1 over 5. Now in order to end up with a positive 1, both signs need to be the same. Okay, well let's wrap this up. Hopefully it's been helpful.